Hi everyone, we are on Unit 8, Lesson 3, and that is an introduction to piecewise functions. And pretty much we'll start with what is a piecewise function. So a piecewise function, they're just taking different pieces of graphs and putting them together and making one function out of it. So you identify it with different parts of the graph, and then you make an equation for that graph, and then you limit the domain to identify that you only want a specific piece of that function. So an absolute value function, you can see here, it could be written as a piecewise function because the two pieces could be the equation of a line on the left-hand side, which you see here, and therefore the domain would be from negative infinity to 0, or the equation of a line, which is the right-hand side, a slope of 1, that's x, and that would be from 0 to infinity. Now, one of the things I want you to notice here for this piecewise function is that you cannot double include a value. So here on the right-hand side, we're including the domain value of 0, but on the left-hand side, we are not. So you need to include this particular domain where they overlap and make sure they don't overlap, otherwise it wouldn't be a function because it would fail the vertical line test. If we included 0 here and included 0 here, it would be double 0, which means you would fail the vertical line test. So to make sure it is a function, hence the title piecewise functions, you need to include the overlapping domain value on one of the pieces and exclude it on the other. All right, so example 1. We have an absolute value function, f of x equals negative 3 times the absolute value of x minus 2. And we want to rewrite this equation as a piecewise function. But first, let's go ahead and graph it. So we know that an absolute value function usually looks like a V, but because we have a negative in front, it's going to open down because we have a vertical reflection. This information here tells us we're going to move right 2. There's no other up or down. So now we are going to go down 3 to the right 1, down 3 to the right 1, because this is the slope of the right-hand side of an absolute value function. So my absolute value function looks like this. Then I reflect it or just repeat that on the opposite side, the left-hand side. And so here is my absolute value function. Now, if I want to write this as a piecewise function, I'm going to write the right-hand side as a function, and I'm going to write the left-hand side as a function. So first, I say the function is, and then I put that little bracket, and I'm going to have the right-hand side and the left-hand side. So I'm going to have the right-hand side, and then I'm going to have the left-hand side. So my right-hand side, well, the right-hand side has a negative 3 as the slope, and we just shifted it over as to 3x plus, 3 times the quantity of x minus 2. But that is only with the domain of 2 to infinity. So we started at 2, and it continues onward toward positive infinity, and that would be the right-hand side of the graph. Negative slope, down 3, right 1, down 3, right 1. The left-hand side has a positive slope, up 3, right 1, up 3, right 1. So it's positive 3 times x minus 2, but we are going from negative infinity to 2. Now, I am going to exclude the 2 here in the second one because I included the 2 up there in the first one. Of course, you could have reversed it. We could have excluded the 2 on the first one and included the 2 on the second one, and that would be fine as well. We don't care where you include it and where you exclude it. That's really going to be your choice. Now, you could also write this function and distribute, right? We could write that as negative 3x plus 6, and that's from 2 to infinity. And then the right-hand side would be 3x minus 6, and that is from negative infinity to 2. And you can see here we have a y-intercept of -6 and then a slope of +3. Or if we continued that pattern here, we would have a y-intercept of +6 and a slope of -3. So either of these are acceptable. We will accept this as your original piecewise function, or we will accept this here. They are both fine, and of course you can alter these domain restrictions if you would like. All right, this question should look familiar from the beginning of the school year, taking you way back. We talked a little bit at the beginning of the school year if a function is continuous or discontinuous. If it's continuous, you should be able to continue graphing the entire function without lifting your pencil off the page. If you have to lift the pencil off the page, like here, we would lift the pencil up off the page to go to here. So this function, h of x, is discontinuous. There's usually a hole or a gap somewhere, so we go across, have to lift my pencil up and start again. So go ahead and pause the video and try to answer these questions, and if you want, you can even try to write a piecewise function. So go ahead and pause and try this one on your own. Okay, are these the answers that you got? So the first one is h of x a function. Yes, it is, because if I do the vertical line test, it's going to pass the vertical line test. Even here, undefined up here, defined here, so yes, it passes the vertical line test. Is it continuous? No, we had a gap there at 1, so we had to jump, pick up our pencil. What is a domain? Well, it goes from -3 and it continues to go on to infinity. It is defined at 1, it's just you jump down here to define it. What is the range? Well, we start here at 1 and then it goes infinitely upward, so it goes infinitely, so it's from 1 to infinity. If you plug in a 1 for x, what are you going to get for y? Well, when we plug in 1, this is where you had a closed circle, so the y value is 1 when x is 1, and then write a piecewise function. Well, a horizontal line is just going through 2 on the y-axis, so your horizontal line is 2, so y equals 2 for -3 to 1, so including -3 and excluding 1. You must have an exclusion here, there's no option because it's an open circle. Or y will equal your line x, so here this is a line x, but it's starting at 1 and going to infinity. It has to include 1 this time because it's a closed circle, and then it's going infinitely to the right. So this right here, how we write it, I didn't really explain that last time. It's your function equals, and then we have this part, and you just list it in the parts that you have, and then you can put a colon after it and list the domain associated with that particular section of the piecewise graph. All right, here is another piecewise graph. We have 3 different pieces, right? Hopefully you see that. We have this part here, which hopefully you're thinking to yourself, that's part of a parabola. We have this point here, it's just a little dot. And we have this portion of the equation here. So we actually already gave you the equations. So this time, all you're gonna do is work on your domain restrictions. So you would say f of x equals, we are going to have 3 portions. So I'm gonna have the quadratic portion, I'm going to have the green point portion, and then I'm going to have this red line segment portion. So go ahead and pause and write what you would think you would need to for each section, including the domain. All right, is this what you got? So for the parabola, the equation is y equals x squared, and so I put y equals x squared, but it's only for this portion of the domain. From -infinity to 2, it's an open circle, so we're excluding -infinity and we're excluding 2. Then I have just a point. The equation is y equals 6, so y equals 6, but that's only when x equals 2. So when x is 2, y is 6, that's a point right there. For this red segment, we gave you the equation. The equation is 10 minus x, so y equals 10 minus x. but that is only under from 2 to 6 on the domain. It's an open circle here, so I exclude the 2. It's a closed circle here, so I include the 6. So that is it for your piecewise function for example 3. All right, hopefully you're starting to get the hang of this a little bit. It's going to get more complicated as we see more complex functions. So for this next example, we're going to say f of x equals, and then we're going to have 3 sections. So I'm going to have this portion here on the left-hand side is my blue. Then I'm going to have this next portion, I'm going to make it green. And then this last portion, I'm going to make red. So if you want to pause, go ahead and pause and try to come up with these 3 equations and see how you do. All right, is this what you got? Sorry, I moved it down. Didn't have quite enough room there on the right-hand side. So I had my blue portion, that is an equation of a line. So y equals just this equation of negative x because I have a negative slope and it goes through 0, 0. So where that's from negative infinity to negative 1, right? Down 1, left 1, down 1, or sorry, down 1, right 1, down 1, right 1. And if I kept going, it would go through 0, 0. So it's just a negative x. Then this green portion goes from negative 1 to 2, open circle, so excluded, closed circle, so included. Notice this was a closed circle up here, so included. It's just a horizontal line going through 2, so that's y equals 2. Then I'm up here, I have this, hopefully you're saying it looks like a square root, so it is a positive square root. I shifted that to the right 2, so it's the square root of x minus 2. And it's an open circle, so it's excluding 2 and then going until we get to infinity. So those are the 3 portions to make the piecewise function. And it is a function because it is passing the vertical line test. All right, now we're starting to get a little more complex. How about we give you a piecewise function and you have to draw it over here on the graph. So this first one, I'm going to make it red. My second one, I will make blue. And my third one, I will make green. So the first one says that we are going to have y equal to negative 2. So that's like y equals negative 2 from negative infinity to negative 4. So that's what this says here. For x is less than or equal to negative 4. So I'm going to go 1, 2, 3, 4. That's negative 4. Down to, it's inclusive of the negative 4. It's going to be negative 2 forever and ever as I go to the left. So it's just a horizontal line from negative infinity to negative 4. Then it's closed dot on negative 4 because it's inclusive. The next portion is y equals x plus 2. So now I'm looking at this portion here. And that's only, from negative 4 to 1. So from this section here, negative 4 to 1, I need to make an equation of a line that goes through 2 on the y-axis because this is the y-intercept. And I have a slope of positive 1. So I'm going to reverse engineer that. So here I'm including 1 so I can do a closed circle. So I'm going down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. It's an open circle here, but it doesn't matter because the red portion already has the closed circle. So we could just do a connection like this. And if I was doing all the same color, it would look like those are just part of the same graph. There'd be no jump. It would be continuous so far at that point. And this last one, I hope you are identifying as an equation of a parabola. So I have negative x minus 1 squared plus 2. So I can see my vertex is 1, 2. So I go to the right one, up 2. I am exclusive, right, at my 1, so that means I should have an open circle there. So I'm going to exclude and do an open circle and this is from 1 to infinity, so it's for the rest of the graph. So this is my vertex. It's opening downward. So I'm going to go right 1, down 1, right 2, down 1, 2, 3, 4, right 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. It's off the graph, but it would look something like this. Sorry, it should be curved nicely and then going down infinitely. So it should look something like that. So there are my 3 pieces. So I have -2 horizontally from negative infinity to -4. Then I have x plus 2, a linear equation that goes through 2 on the y-axis with a +1 slope. So it goes up 1, right 1, up 1, right 1, goes through 2 on the y-axis and stops here because it stops at 1, inclusive. Then I jump down here, I'm exclusive, and it goes down infinitely. So now this says, what is my overall function's domain? So my domain goes from negative infinity to positive infinity, right? It goes negative infinity, keeps going. Even here at 1, it's defined, and then it's going to go infinitely to the right. My range, however, is not negative infinity to infinity. This goes down infinitely, so I'm going to negative infinity, but it stops here. It gets no higher than 3, so my range only goes to 3, and it's inclusive because I have a closed circle here at 3 on the y-axis, and so that is my overall graph's range. So this would be your picture in the end of the function, piecewise function that was given g of x. You would need all 3 of those pieces to graph your piecewise function. And so that is it. There's a little bit more to it than that. I will explain as problems get more complicated, but try these on your own. We have one more lesson together where we will do maybe more complex functions on Thursday, and I will show you some other strategies with using absolute value instead of a linear function. So we'll talk more about that on Thursday. Have a great day.